Hi, this is Mr. Snyder with Truman Middle School, and today's lesson is on scaling three-dimensional figures and to see the effects that these scale factors will have on the area and the volume, respectively. So first of all, let's go ahead and start off with two cubes, one of them being a small 3-inch by 3-inch cube, the other being a larger 9-inch by 9-inch cube. If I wanted to find the ratio or scale factor of these cubes, I could put the side of the larger cube over the side of the smaller cube. In other words, just put the dimension of the large over the dimension of the small. And you'll find out that the scale factor is 3. So we're going to be finding scale factors and also looking at the effects that those would have on area and volume. So let's go ahead and look at example 1. Find the scale factor for each pair of cubes. So first of all, I need to find the length of the side of the larger cube, which is 16, and the length of the side of the smaller cube, which is 4. And of course, 16 over 4 will reduce to 4. So our scale factor on that particular shape is simply 4. Let's look at our next cube. Our next cube, we have a small one that has a side of 9 feet. The larger cube has a length of 27 feet. So obviously I would just put 9 feet over 27 feet. And we'll simplify that to 3 because obviously, we'll simplify that to simply 1 over 3. So in this case, our scale factor is a fraction, which means we're reducing it in size. On the third example, we have the larger cube with a length of 78 millimeters and the smaller cube with a length of 18 millimeters. So I would simply put 78 over 18. And remember, the unit in this case is millimeters. Since 18 does not go into 78 evenly, we can simply divide out the largest factor that these both share, which I believe is 6. So we'll go ahead and divide out a 6. Six goes into 78, I believe, 13 times. And 6 goes into 18 3 times. So our scale factor in this case will be the improper fraction 13 over 3. So that's how you find scale factor, which is part of our mission, but really we want to see the effects that these scale factor ratios have on the area and volume of certain figures. So again, we will start the problem the same that we've been doing and that is by finding the scale factor. So we want to put smaller over larger, which in example 4 is going to be 16 over 64. And we can factor out 16 from both the top and bottom. And that will give me an answer of 1 over 4. So our scale factor in this case is 1/4. So to see the effect area would have over this, if I have a shape that is 1/4 the size of another, then the area is going to be the scale factor squared because we're going across 2 dimensions. So we're going 1/4 times over 1 dimension and 1/4 over the other dimension. So essentially 1/4 times 1/4, which in this case is going to be 1/16. So just like in the example above where you see the cube, the large cube has a edge length of 9 inches, the small cube has an edge length of 3 inches. So the scale factor is 3, but since we're going across 2 dimensions, we really are going to take that scale factor squared. So really one of the areas is going to be 9 times bigger than the other area. And similarly in problem 4, since we were going from large to small, the scale factor would be 1/4, and since we're doing area, we would square that, and so the area would be actually 1/16. Let's go and look at the effect it would be for volume. So remember from my previous example, if our scale factor is 3 and we are now going across 3 dimensions, we are really multiplying that scale factor 3 times. So the volume of the small shape related to the big shape now should be a factor of 27. Because remember, the cube was 1/3 of the size of or 3 times the size of the original cube, and the area was 3 times 3. So now the volume is going to be 3 times 3 times 3 for a factor of 27. So let's see how this looks in problem 5. So we need to put larger over smaller, so 100 over 25, which gives us a scale factor of 4/1, or just 4. And if my scale factor is 4 and I'm comparing the volumes, then I'm really going to have a scale factor of 4 across all 3 dimensions. So this is really going to be 4 to the 3rd power, which really means that it's going to be 64 times the size of the other. Because 4 times 4 times 4 is 64. So if I find the volume of one, when I find the volume of the other, one should be 64 times the size of the other. For number 6, we'll do something similar. We'll go ahead and put the small above the large, so 6 over 36. That simplifies to 1/6. So our scale factor is 1/6. And if I'm doing scale factor across volume, that means across 3 dimensions. So I'm really going to do 1/6 of the length times 1/6 of the width times 1/6 of the height, or just 1/6 to the 3rd power, which ends up being 1/216th. So that means that one of the cubes should be 1/216th the other, or you could think of it the other way. One of them is 216 times bigger than the other. So you can apply similar techniques to solve the volume of cylinders, but really we just want to show you the effect that a scale factor has across more than one dimension. So for distance, the scale factor is just the scale factor. For area, the scale factor is going to be squared, and for volume, the scale factor will be cubed. And that's really it. That's all we wanted to get across in this video. So we'll let you try your homework, and that's it.